Last summer, an AI sat the hardest math exam on Earth, the International Mathematical Olympiad, and walked away with a gold medal. The same kind of AI, handed a set of everyday clock faces and asked to read them, gets the time wrong about half the time. A schoolchild does better. This is not a joke, and it's not a glitch. It is the single most important and most misunderstood thing about artificial intelligence right now. So how can one machine be a genius and a fool at the very same time? Let's open it up. First, the genius. In July 2025, Google DeepMind pointed an advanced version of its Gemini model at the International Mathematical Olympiad. These are problems so hard that the smartest teenagers on the planet train for years just to attempt them. The AI solved 5 of the 6, scoring 35 out of 42. Gold medal standard. And crucially, its answers were graded by the official Olympiad judges, using the exact same rules as the human students. It wrote real proofs in plain language inside the time limit. This is not a search engine looking things up. This is genuinely, breathtakingly hard reasoning. Now the fool. A researcher built a simple test called ClockBench. Pictures of all sorts of analog clocks, some plain, some fancy, just read me the time. Ordinary people score around 90%. And the best AI in the world, as of 2026? About 50%. A coin flip. It stumbles hardest on Roman numerals, on second hands, on anything slightly unusual. And here's the thing that should stop you. This is the same class of model that just won a math Olympiad. It can outreason a gifted teenager, and it cannot reliably read the clock on your kitchen wall. There is a name for this. Researchers call it the jagged frontier. Picture the edge of what AI can do, not as a smooth line running from easy tasks to hard ones, but as a jagged mountain range. Towering superhuman peaks like Olympiad math, sitting right next to valleys that dip below a small child. And the most dangerous part is this: the edge is invisible. You cannot look at a task and guess which side it falls on. Something that feels trivial can be a valley. Something that feels impossible can be a peak. So the real question isn't which side is the AI on, it's why. Why would the very same system ace the impossible thing and flunk the trivial one? Once you see the answer, the whole jagged shape suddenly makes sense. And it comes down to how these machines are actually built, and what they were, and were not, trained to do. Start with what a language model fundamentally is. At its core, it does one thing. It predicts the next little piece of text over and over. It is not running a fixed procedure the way a calculator does. It is continuing a pattern, the most likely next step, based on everything it has ever read. Now, modern models are clever about this. When they slow down and write out their reasoning step by step, they get dramatically better, because each step gives them a little more room to think. But underneath, it is still prediction, not guaranteed calculation. And that single fact explains both the peaks and the valleys. Here's the peak. Why is it superhuman at math and code? 2 reasons, and they work together. First, math and code are everywhere in its training data, textbooks, proofs, millions of solved problems. And second, they can be checked. You can automatically tell whether a proof is valid or a program runs. So the labs could let the AI practice these tasks billions of times, keeping what worked and throwing away what didn't, grinding it towards superhuman skill. The rule is simple. Wherever the answer can be verified, the AI can be trained to greatness. Now the valleys, and the first one is a classic. For years, if you asked an AI how many times the letter R appears in strawberry, it would confidently say 2. The right answer is 3. Why did it trip on something a child can do? Because the AI never actually sees letters. Before it reads anything, the text is chopped into chunks called tokens. Strawberry isn't 9 letters to the model, it's just 2 or 3 of these chunks. Asking it to count the letters is like asking you to count something sealed inside a box. Newer reasoning models mostly get this right now because they slow down and spell the word out. But the reason it ever happened tells you something deep. The model's world is not made of the same pieces as ours. Which brings us to the clock. And there are 2 things stacked against it. First, clock faces are rare in training data, and weirdly repetitive. Many clock photos are set to 10 past 10 because that's how watches are sold. So the AI never really learned to generalize to every possible time. But the deeper problem is vision itself. An AI does not look at an image the way your eye does. It chops the picture into a grid of little squares and turns each one into numbers. That's fine for recognizing a cat or a face. But reading a clock means measuring the precise angle of 2 thin hands, and turning that fuzzy, blocky impression into an exact measurement is exactly what this kind of vision is worst at. So now step back, and the whole picture snaps into focus. Tasks that are dense in the training data and easy to check like math and code got polished into superhuman peaks. Tasks that are rare, messy, or need precise perception, like reading a clock, measuring an angle, counting inside a word, were left as valleys. It was never about what feels hard or easy to us. The frontier follows what the machine could practice and verify. That, and nothing about human intuition, is what carved this jagged edge. And this is why it actually matters to you. The real danger of AI today is not that it's dumb, it's that it is brilliant and clueless at the same time, and it sounds exactly as confident when it's wrong. The frontier is invisible. In one careful study, people given an AI for a task just past its frontier did 19 points worse than people with no AI at all, because they trusted an answer that was delivered with total confidence and was completely wrong. So here is the rule the jagged frontier gives you. Never assume competence carries over. The fact that an AI just aced something hard tells you almost nothing about whether it can do the easy thing sitting right next to it. Impressive and unreliable live in the same box. Always verify. This jagged edge is the true shape of AI in 2026. Not a smooth climb toward being uniformly smart, but a spiky, shifting frontier, one that moves every few months. That clock score jumped from 13% to 50% in under a year. Understanding why the peaks and valleys are where they are is what separates people who use AI well from people who get quietly fooled by it. That's what this whole channel is for, taking apart how these machines really work one idea at a time. The full course is free right here. Subscribe and you will never look at the frontier the same way again.